Assalamu alaikum. So, in this video, we'll be going over a doubly linked list in the data structures and algorithms course. This video will be covering the basics of a doubly linked list, how to insert nodes in a doubly linked list, and then how to delete nodes in a doubly linked list. Most of these things will be done at the start of the linked list at any location except three invalid cases, which I'll go through in a minute, and then at the end. Okay, so without any further ado, let's start. Let's just jump right into the video. So, what is a doubly linked list? First off, we have to understand what a linked list is. Well, a linked list is a way of storing data in an organized way, much more like an array, but it overcomes the limitations of an array. Okay, so this basically there's three types of linked lists. One is a singly linked list, a doubly linked list, and a circular linked list. So we're gonna keep going through the doubly linked list in this video. So basically, a linked list has its limitations as it is a one-way linked list. Basically, what it means that in a singly linked list, we can move from one node to another node uh, in only one direction, in a forward direction. Okay, because a node in a singly linked list has one directional pointer, which is the next pointer. So basically, in a singly linked list, links are only created in one direction. So to to get over this problem, इस problem को खत्म करने के लिए we have a doubly linked list. ठीक है? So a doubly linked list, a node in a doubly linked list has two directional pointers, one pointing to the next node and one pointing to the previous node. So this is like, as you can see, structure of a node in a doubly linked list. So we have a previous pointer which points to the previous node, a data part which contains the data of that node, and then a next pointer which points to the next node. Okay, so uh, we have four pointers over here, as you can see. I like to use this method called global pointers because it helps me to like initialize all the parts of the node beforehand and not just write a list node and initialize the pointer every time I want to use it. So I just like to like write global pointers, like which is like outside the functions and outside the structures and classes, all that. Yeah. Before that, we have the blueprint node, which is basically how a node is designed, how a node is structured. So we have the previous pointer. As we can see, we made a structure called list node, and then we made a pointer in the structure called previous, prev. Then we have the data part, which have in data, and then we have the next pointer, which we also have from the structure. So basically, these three things, as you can see, previous, data, next, are basically a blueprint node, which means the structure of a node. Okay, so if we're gonna go down, we have the conditions for node insertion. Okay, now we're on to the main point, node insertion. So to insert a node in a doubly linked list. So first off, if we have the linked list is empty, which means the linked list doesn't exist. We have to create a linked list. Then, if the linked list is already created, we have to insert a node. So, jumping right in, same as ever, at start, at any location, and in the middle, at the end. Okay. So, basically, we can insert the node at the start, in the middle, at any location, and at the end. Okay. So, the invalid conditions, yeah. I've written the invalid conditions in this in the past when I did the singly linked list. So you have to keep these in mind. So I have written three numbers. We have to keep these three numbers in mind. See, 1, 2, and 3. So the first invalid condition is the desired location is a negative number. So what this means is the user entered a location and that is a negative number. Okay, obviously the location cannot be negative because if it's negative, the linked list just simply won't. It can't comprehend a negative number as a location. Okay. Then we have the desired location is greater than n plus 1, where n is the total number of nodes. It is pretty self-explanatory. If we have n number of nodes, for example, we have 10 nodes, and the user wants to place a node at the 12th location, like greater than n plus 1, which means it's greater than 11, which means, for example, 12th or 13th node. Well, that is simply not possible, because in a linked list, each node is connected to is connected to the previous or the next node. So if there is no node to connect the previously linked list to the current node, the linked list just simply won't exist. So, like, if we have the desired location is 12 and the total number of nodes is 10, that is an invalid condition. Third condition is the head pointer is null and the desired location is greater than 1. Well, what this simply means that the linked list does not exist. So, like, which means the head pointer is null. I'll go over through these pointers in a minute. So the linked list does not exist, and basically, if the head pointer is null, which means that the linked list hasn't even started yet. And then, if the location is greater than 1, which means if the linked list hasn't started, and the location is greater than 1, it's an invalid statement, because if we want to start a linked list, we have to put it at the first location. So we have to keep these three conditions, invalid conditions, in mind. I'll be writing 1, 2, and 3 wherever I explain or like write the code for these conditions. Okay. So on to the W linked list now. So if we get started with the code, okay, I've made three functions. I made a function of inserting at front, which has which we're gonna passing the value. Whatever the value is passed, it's gonna come through here. So for the first line, it's actually not necessary to like write list node then like this whole line, because we've already done it over here. So if we just write node is equal to new list node, it's going to create another one, a new node anyway. Okay, so I've written comments, so it's like easier for you to understand. So we just created a new node over here. Then node data is equal to value. So basically what this means is that the node that you just created, its data portion should contain the value that is passed over here. So for example, I passed 10 over here. So the node's data portion will contain the value 10. Okay. I've also like made some diagrams. Yep, over here. So we have this. We have over here. Okay, so we have this node. We have this node that we're gonna create. So we just created a node. This is the first step. We just created a node 0xf100, and this node is also created in the memory. Okay, so this is the first step. Okay, now next we're gonna store the data. Yep, we've already stored the data over here, as you can see. I write in step C 1, 2, 3, 4. This is all like a stepwise procedure. So we just made a node, first step. Okay. Then the second step, we stored the data 2. Okay. And in this case, yep, this is step 2. Okay. We just stored the data 2 over here. And then what's this third step? The node's previous pointer is equal to null. So it says that the previous of the node that we just created should be null, because it's the first node, and the previous pointer of the first node of the linked list is always null. So we just did it number 3, as you can see. Number 3 is equals to like basically we just made the previous pointer null. Okay. Next up, we have a condition. So we're gonna check if the head of the linked list is null. Basically, if the linked list exists or not. Well, if the linked list does not exist, we're gonna make the node next is equal to null, which in our case, the linked list did not exist earlier. Okay, so we're creating a new linked list, as you can see that with from a heading. When we're creating a new linked list, we make both the previous and the next pointer null, because there's only one element in the linked list, and the first element of the linked list's previous pointer and the last element's tail pointer, next pointer basically, are both null. Okay, so basically this is the first and the last element. So both the directional pointers will be null, as there's nothing to link them with. As you can see, I've written like the fourth step over here. Okay, then we're gonna assign the node to head and assign the node to tail. So as you can see, this is a node. We've assigned it to head first, as you can see, the fifth step, and then we've assigned it to tail and next. Okay. So that was the condition for an empty linked list. Okay. Now as you can see, the above if statement creates a linked list after checking the head pointer to be null by adding a node. Okay. So the next is if a linked list actually exists, okay, which in this case it does. Hold up, I'm sorry. Yeah, in this case it does, okay. So the linked list already was existing over here at first, as I showed you. Like we created a linked list, we added a node, and now over here we're gonna add a node before the existing node, okay, inserting at the start, okay. So what we have is node next is equal to head. So okay, let's recall it. So we have this the node which we're gonna be adding. So the node pointer is always gonna be the node that we're gonna be adding or deleting. Okay. So the node pointer we're gonna initialize node as from the it starts from the first again. Okay, from the function. So we initialize the node. We made the node, created a node. Okay, it's the first step over here. As you can see, I've written number one. We've created a node. Okay. Then we're gonna put the value in the node. For example, take one. We added one over here. Node data is equal to value. See, the data portion of the node will contain the value one. I've written number two over here. Then number three, node previous is equal to null because it's the first node. We're adding the first node, so its previous is gonna be null always. Number three is here. Okay, and then number four, we're gonna come over here. We're gonna skip this because the linked list is not null. Because the linked list exists, we're gonna still skip this portion because well, it's not an empty linked list. Okay. Next we have this one. Node next is equal to head. Okay, now we're gonna see what was head. The head was previously 0f100. This node, like so as you can see, this node was the head of the like previously the head of the linked list. But now we're gonna assign the node's next pointer to we're gonna assign head to node's next pointer. So head is this 0xf100, and this is the node that we're adding. So the next pointer of the node is going to be assigned the head value, okay? And the head is this, okay? Next up, we have head previous is equal to node. We ignore the second line because we've already done that over here. Head previous is equal to node. So we're going to assign node, this like the node we're going to be adding to head. What is head? F0xf100. So 0xf100's previous is going to be assigned the node, okay? So like to make a complete link. So we have this head, and in this previous pointer, we assign the node. So as you can see, I assigned the previous pointer of the head to node. And this is the fifth step. Okay, I've written the codes here as well. Head previous is equal to null, node next is equal to head. It's for better understanding, okay? And finally, we're gonna be updating our head. As you already know, that the head is the first node of the linked list. So we're gonna be updating our head to contain the value to contain the node that we just added at the start. So as you can see, I've updated the head, which is the sixth step. Okay. Now we've done creating a linked list. We've done inserting at the start of the linked list. Now we're gonna be moving on to hopefully inserting at the end of the linked list. Okay. Now, to insert at the end of the linked list, what you basically want to do first is the basic steps are all the same. We're gonna get the value. We're gonna get the value passed. Yeah, so we're gonna make make a new node in the dynamic memory. Then we're gonna store the value in the node's data portion, as you can see over here. We created a node. Okay, sorry, inserting at the end. Okay, this is a new thing. Okay. Starting at the end, we created a new node at first. The first step is always creating a new node dynamically. Okay, we created a new node. We firstly stored it in the node pointer. We created a new node in the memory. It created a new node as well, heap memory dynamically. Okay. Then the second step was to store the data, which we just did. We stored the data in the data portion. The second part was done over here. What we have next. That node next is equal to null. So now as it is the last pointer, the tail pointer, the last pointer's next is always null. Okay, the last node, sorry, my bad, not pointer, node. The last node's next pointer is always null. Okay, the last node is also known as the tail pointer, whose next pointer is always null. Okay, so we made it null, as you can see, the third step. Next, we want to do nodes previous is equal to null. So okay, for the first For the first, for initially, we're just gonna keep this null until we have it's already null basically, so we don't have to keep it null initially. Uh, Sorry, initially we're gonna keep this null, the previous of the node, because it hasn't yet been it hasn't yet been linked to any of them yet. Okay? We're getting to that point, inshallah. So now we're gonna check if the linked list is empty or not. If the linked list is empty, it's gonna assign both. It's gonna assign the node to both the head and tail, which means the linked list only has one element, one node, which in our case is not the case. So we're gonna skip this part and move on. Next we have else. Else, if the linked list is not empty, this code will run. Node node previous should contain the tail. So the node's previous should contain the tail. So this is the node. This is the node's previous. Sorry. This is the node, and this is the node's previous, and it should contain the tail. What's the tail? Tail is, yeah, the previous tail was 0xf100. This node. So the previous tail should go to this node's previous to like create a link. Okay. So as you can see, I've mentioned it. That code also here as well. That number 4 step should be that we have to link the previous tail to the new node. Okay. Then number 5, tail next is equal to node. Again, the previous tail is this node. Okay. So we're going to link the next one, the next pointer of the tail pointer of the tail node to this node. Okay. As you can see, I've written 0xf102, which is the address of this one. So it makes a link. This points to this points to this. Nicely two-way link has been formed. Okay. Now our linked list is like updated. Okay. Next, we just have to assign the node pointer, the node pointer to tail, because it has updated our last element. And as you know, the tail pointer always has to contain the address of the last element. So we just update the tail pointer to this. It points to this now. Okay, this the last node. Well, that's basically it for the inserting at the end. Now we have to insert at any location. Okay, now if we're gonna recall, before that I explained 3 invalid conditions for inserting nodes at any point. Well, now this is the time where we like actually see them in action. So basically, we create a function insert at any location, which has 2 parameters. One is the data itself, the data we want to add at the data portion, and then the location, like where in the linked list do you want the node to be inserted. Okay. Now, if you move on, the first check we have is that if the location is less than 0, if the desired location, this one, is less than 0. Now, if the location is less than 0, which means it's a negative number, I told you guys to recall these conditions. The first condition is the desired location is a negative number. So as you can see, I wrote 1 over here, which is desired location is a negative number, which means it is an invalid request. So we just return invalid request, and then we move on. Next, we have another check. Another check to see if the head pointer is null and the location is greater than 1, which means I told you if the head pointer is null, this means that the linked list does not exist, and that we cannot insert at any location except 1. And if we insert at the first location, this means that we're also creating a linked list. So this is the third condition. As you can see, the head pointer is null and the desired location is greater than 1. The linked list does not exist. So I've written 3 over here. Okay. Now next we move on, as these both conditions are like let's just move on. Okay. Next we have else. In else, obviously, if we've already passed the condition check, else we're gonna create a new node. As you already know, we're gonna create a new node dynamically. Same process as over here, but we're just gonna be inserting it in at the desired location. Okay. Let's just let me just explain it to you with the help of the diagram. Okay. So we already have a three node linked list. Okay. Suppose we have to let's look over here, insert at location 3 and 3. So we have the data as 3 and the location as 3 as well. So we're gonna insert between these 2 nodes. Okay. So this is the 2 and this is the 3rd. So this is gonna insert, the node is gonna be inserted over here, making this the 4th one then. Okay. So we created a new node. As you can see in the node, we created a new node is 0xf101. See, I've written steps. See, first step over here is we created a new node in that heap memory. Okay. Okay. Next up, we save the data. We save the data that we're passing in the data portion. So data we passed 3, and we stored it in the data portion. As you can see, I wrote 2 over here. So like steps. Next, we're gonna check. We're gonna check if the location is equal to 1. Well, this basically checks if the linked list is empty and the location is equal to 1. I mean, not really. It doesn't check if it's empty. It just checks if the location is 1. If we're inserting at the start, okay. So if the location is 1, it's gonna run the code to insert at the start. If head, it's gonna go through the same procedure that we were going through over here. It's gonna run the same code, okay. It's gonna check if the head is null, and then it's gonna execute this code, and then if the head isn't null, it's gonna like, well, if the head isn't null, it's gonna like just pass on, like just ignore this code and move on over here, which in our case head is not null, so we're gonna move on over here. Let's just explain. I'm just gonna explain. As our location is not 1, I'm just gonna explain just what's going on over here so that it doesn't like. Okay, so the else code, the linked list isn't empty inserting at the start. It's just an example. Okay, I've already explained this to you in previously, but I'm just going to explain it just for the sake of this code. Okay, head previous is equal to node, the address of the added node stored in the previous of the existing head. Again, we're gonna be adding at the start. So the existing head's previous was null, so we're gonna store the node's address in the previous of the existing head. Okay. Next is node next is equal to head. We're gonna store the address of head, the previously existing head, into the node's next, so that we can have a two-way link established and the node is placed at the start. Then we're gonna put null in the node's previous pointer, which I told you that the head pointer's previous is always null. Then we let head is equal to node, which updates the head. Okay, and it's the same as the previous one. Okay. Next we have for any other location, we're gonna start traversing. Okay. Now what basically traversing is? Traversing is the process of visiting every single node in the linked list. Okay. Now, yeah, now how this is done is that we establish a temporary pointer, as you can see over here, that I've established a temporary pointer over here, 0xf0099, which starts at the head. Okay, so we assign temp is equal to head, and it's going to start at the head and start traversing from here. Okay, how this basically works, how this basically goes on, is a for loop where we're gonna int I is equal to 1. We're gonna initialize a variable. 1 is equal to basically the first node, which is head. Then we're gonna move on until this variable is less than location minus 1. For example, in this case, our location was our location was 3, so it's gonna move to location minus 1, which is less than location minus 1, which is 2. So I is gonna be less than 2. For in this case, I is 1, which is already less than 2, so it's gonna run once. Okay. So we're gonna add it's gonna increment if the condition is still not fulfilled. So in our case, this loop is already gonna run once because it's 3 and 3 minus 1 is 2 and 1 is already less than 2, and in the next iteration 1 is gonna be 2, so 2 is not less than 2, so like the condition gets negative, but in our case it's gonna run only once. Okay. Next we have it's gonna run, it's gonna move the temporary pointer to the next of the temporary pointer. So basically, if we're starting traversal over here, okay, the temporary, so this is going to be our first temporary pointer, okay, temporary node, and then when the loop runs, it's going to shift onto the temp is equal to temp next. So it's gonna, in temp next has this node, which is basically this node, so it's gonna shift the temp to over here. Okay, I couldn't write it over here, so yeah, I did write over here, as you can see. So temp is equal to temp next. We're just basically moving the temporary pointer to the next node. Okay, over here. Okay, I've actually written like the steps as well. Hold up. Yeah. So first we create a node. Second, we store the data. Third, we create a temporary pointer. Fourth, we're getting to that part. Okay, Achha. Temp is equal to temp next. Now our temporary pointer is at this node. Sorry, this node. Okay. Next we're gonna be updating. Yeah, we just did it. We're updating temp to the next node. In simple terms, temp is equal to temp plus 1. In programming fundamentals, if like for understanding purposes only. This can also be like, this is also be like pseudo coded into temp is equal to temp plus one. Okay, it can't be written as that, but it can be, explained. Okay. Next, if temp is equal to null. Now, if the temporary pointer is null, which basically means that our location is out of scope, the loop will break and will come on to this. Okay, if the temp becomes null before the desired location is visited, it means that the desired location is out of scope and that the request is invalid. Loop breaks. The loop will break and the control will shift over here. It's going to check again if temp is equal to null, see out invalid request. It's the second condition, second invalid request. Okay, if we move back over here, over here, yeah. The desired location is greater than n plus 1, where n is the total number of nodes. Over here, it's the same thing. If temp is equal to null, for example, the temp reaches for example, the desired location we have a three node linked list, and the desired location is, for example, 6. Now, after the three nodes get traversed, the fourth node is going to be null because the fourth node does not exist, and temp obviously will then contain the value null. So if that happens, the loop will break. It comes over here and it checks if the temp is null. Then it will output invalid request, which is our second invalid condition. Okay, it's basically yep. I've written it so that we can like stop just explaining it again and again, because I think this is gonna be coming in the future as well. Well, if the temp is not equal to null, and it's in the else statement, okay, which means that our location is in scope. If the temp is not equal to null, it's just gonna insert that node in the linked list. So temp next is equal to node. So what we had, temp is this. So we're gonna store the next of the temp and give it the node's value, which is this one. So we make a link first over here. As you can see, I just stored the next of the node. Sorry, the node in the temp's next. Okay. Then we assign the temporary pointer to the node's previous. This is the temporary pointer. This is the node, and this is the node's previous. We assign the node's previous to the temporary pointer. Okay. As you can see, I've written the address of the temporary in the node's previous. Okay. I've written this as well. Okay. Next, we have the node next is equal to null. This was a node. And this was the next node's next. It's gonna be null. Condition is that it's gonna be null when it's gonna be added at the end. Okay, at the end of the linked list. As you can see, if temp next is equal to null, which means that the temporary pointer's next pointer is null. So basically, if the temporary pointer is the last pointer and we want to add at the end of the linked list, okay, this code is for adding at the end of the linked list, okay. And then we assign node to tail. It's basically the same code that we used to insert at the end, but in this case, in this function, we have to add it because the location can be at any point. It can be at the start, it can be at the end, it can be in the middle. We don't know, okay. Code to add the node if the location is right after the linked list. I've written it over here, okay. So I'm sorry if you misunderstood anything, okay. Achha. Else, now we move on to the desired location part, okay. If the desired location is not the start or not the end, but in the middle, okay. Now, so we have the condition right in the middle of the linked list. What we're gonna do is we have this as temp, this pointer as temp. What we're gonna do is we're gonna look at the the temp's next node, and then that node's previous pointer, and we're gonna store node. Okay. So what is temp? Temp is here, and what was the next of the temp? It was this one, as you can see over here, temp, and the temp's next is this one. We're gonna store the next previous pointer, meaning this pointer. We're gonna store the value of the node in it. Okay, so that there's a link formed. Okay, as you can see, I've written temp next previous is equal to node. Okay, this was the first step. Next, I'm just gonna read it. Suppose we want to insert at the 5th place in a 6 node linked list. Temp starts at the first node and the loop goes on until I is less than location minus 1. That is 5. I is less than 5 minus 1 is 4. So I will be 3 in the final iteration. The loop will move 3 times each time moving temp to the next node. Now temp is equal to node at fourth place. I've already told you temp is equal to the node at fourth place. I mean, it's not the node at fourth place. It's yeah, it's the node at fourth place. Okay, this is an example. Next, the above line of code assigns the existing fifth node's previous pointer to the to be added node, hence creating a link. Okay, we made a we've made a 3 node linked list over here. That this is about a 6 node linked list. So we're just gonna ignore this. Next, we have the next statement node next, which means this node's next is gonna be assigned the temp's next. Okay, so this is the temp, and temp's next. This is the temp. Temp's next is this node. It's gonna be assigned to the node's next. Okay. So like we have a two-way link form over here. I've written node next is equal to temp next. Okay. Next up we have. Okay, that's it. That's it for the next up. Yeah, over here. This assigns the next of the temp, that is the existing, to the next of the to be added node, creating a two-way link now. As you can see, I've just shown this, demonstrated this over here like this. Next up, we're gonna assign the temps next to node nodes node to temps next. This was temp. We're gonna assign the next of the temp to like node, and this we established a one-way link over here. Then we're gonna assign the temp to the node's previous. This was the node. This was the previous. We're gonna assign temp to this. It's gonna contain like it's made a four-way link. Two from here, two from here. It's inserted smack in the middle of the linked list. Okay. Next up, we're gonna move over here. As you can see, I've demonstrated this as well. This was the previously fifth one. This was the previously hold up. Yep, this was the previously fourth one. This was the previously fifth one, and we've inserted the node right in the middle. Now this was the fifth. This is the old fifth. Now the sixth, and this is the fourth. That was a temp. Okay, and then we just closed all the brackets. So this was basically it for insertion. Temp stops at less than location -1. The loop only runs once. In this condition, the loop only runs once. Okay. So we stop here for insertion. Now we move. I'll move on to deletion. Okay. Okay. Now moving on to deletion in a doubly linked list. It has 3 conditions at the start, at the end, and anywhere in between. And it also has 3 invalid conditions, which are gonna be 1, 2, 3. I've explained it. Okay, now let's just start with deleting at the start. It's gonna check if head is equal to null. If head is null, it's gonna return invalid request, which means the linked list is non-existent. Next up, it's gonna check if the head's next pointer is null, which means that there's only one element in the linked list. It's gonna assign temporary pointer to head. It's gonna assign null to head and tail to and null to tail as well, which means that the head and tail are both null, which means there is no node in the linked list. Then it's gonna finally delete the temporary pointer, which had the address of the head. The linked list had only one node. And now that's gone as well in here. Okay, next it's gonna check linked list in case of more than one node. Okay. It's going to assign temp to head. Head is equal to head next. The head pointer is shifted from the first node. As we're deleting at the start, we're only going to be looking at the first node. Okay. When the head is assigned to temp, head's next is going to be assigned to head. So the head pointer is updated, shifted from the first node to the second node, as we're going to be deleting the first node. Next, we're going to delete temp, which had the previous head. Now the first node is deleted. Okay. Now we're going to assign the new head's previous to null, which means, as I already told you, that if whatever head we have of the linked list is previous pointer is always null. The newly made head's previous node now made null, as it was pointing to the already deleted node. That's it for the deleting at the start. It's as simple as that. Okay, next we have deleting at the end. Let me just show you the diagram for deleting at the start, as you can see over here. Okay, we had a 3. We had a 4 node linked list. Okay, over here. As you can see, we had a 4 node linked list, and we deleted this node at the start. Okay, so the first one is that we assign the address of the previous head, this node's address, to head over here. Sorry, what? We assigned the head to temp. So okay, so over here we have temp. We assigned the head's address to temp. The first one, assign previous head to be deleted. Okay. Next up, we did head is equal to head next. We shifted the head from the first node to the second node, which is this node. Okay. Next up is where's the third one? Yep. We're gonna over here. Sorry. Uh, Next up, we have we're gonna delete temp. Temp is deleted. Temp freed, which means this node is now gone. The previous head is now gone, and temp is freed now. Okay. Next up, we have four. Four is we just uh, stored null in the new head that we had. Now this is the basically the new head. Okay. So this was the process. Now we're just gonna move on to deleting at the end. If it's going to check if head is equal to null. If the linked list does not exist, we're just going to output invalid request. Next, we're going to check if head is equal to tail, which means there's only one linked list. It's the same. It's the same as this. It's going to check if heads next is null, and it's the same as this as well. It's just another way of. I thought it would be nice to know more than one ways. Okay, if head is equal to tail, which means there's only one node, which is also the head and the tail as well. We're going to delete head. Simple as that. We're going to assign head to null. We're going to assign null to head and null to tail, which means that the linked list is now empty. Next, if the linked list has more than one element, we're going to be starting from the tail. Okay, as we're deleting the last pointer. In this case, we can move backwards, so no traversing would be necessary. Because we're just going to start at tail. So we're going to assign tail to temp, as you can see over here. We assigned tail, which is this one, which was this one, this node. 0xf102, we assigned it to tail. Okay, over here, this was the first step. Okay, sorry, we assigned tail to temp, which was the first step. Wait a second, hold up. Oh, sorry. This code is for deleting at any location. This is for deleting at the end. So we're gonna take this and we're gonna move it from here. Okay. So first step we had was to assign tail to temp. This was tail, and we assigned it to temp over here, as you can see. Next we have tail is equal to tail previous. Now as we assigned the tail to temp, we're gonna tail is equal to tail previous. We're gonna shift the tail pointer to the previous node. This is the tail pointer. We're gonna shift it to point over here. Now it points to this node. Okay, 0xf100. Okay, as we had written to. Okay. Next we're gonna store tail next is equal to null. We're gonna store next in the tail's null. This was the null pointer. Now this one. Now we're gonna store null in its next node. Okay, and finally we're gonna be deleting temp, which means that now that this node has been deleted, like this node has been deleted from the end. Okay, it's that easy. Logic is the same as deleting at the start. We assign temp to tail. We assign tail to temp, adjust linking directional pointers, and then finally delete temp. Okay. Now finally we're at the final stretch. Deleting at any location, it's gonna provide a location. The user can provide a location. We're gonna check if the location is negative. It produces invalid. Sorry, this equals to sign won't be coming over here. Okay. If location is less than equal to 0, or maybe it will come. Yep, it will come. Okay. Yeah, it's less than. If it's less than that, it's gonna be 1. Okay. If location is less than 1. Okay. It was just another way of writing that. Okay. See out invalid request. The first condition, as I told you earlier, the desired location is a negative number, so the number cannot be negative. Location cannot be negative. The above statement checks if the given location is 0 or less than 0 and declares invalid. Simple. Else, if its head is null, invalid request. Over here, the third location, the head pointer is null, which means the linked list does not exist. So it's gonna it's gonna output invalid request. Okay. Next, in any other case, we're gonna assign temp to head. We're gonna start traversing to search for the node. Over here, we assigned a temp, its head to temp. As you can see, we already have a head over here. So we're gonna be deleting which node from here? We're gonna be deleting the second node. We're gonna be deleting this middle node from here, and we're gonna do this. Okay, so we assign temp to head. Head to temp. Next, we initialize traversal for int I. It's gonna move on. So I will move on till less than 2, which is 1. So the loop will only run once. It runs once. Oh, sorry, the loop won't even run. Okay, because I is already less than 2. Okay, So we're gonna as we're deleting the second node, and this is the temp node, which means that is I is not less than location minus one. Location minus one, we have location two minus one is one. So one is not less than one, which means that the traversing won't happen in this case. Okay, I actually included this code knowing that we've already done traversal. So it's just like a good, another perspective of what would happen if we already have our location that we want. So this loop, the traversal loop won't run. And then it's going to move on to this. Okay? If temp is equal to null, if temp is equal to null, it's going to be cout invalid request, which means the location is out of scope. If the temp gets null, which means this basically means that the node that we're trying to delete does not exist. Okay. Next, we're going to do node is equal to temp next. Node, what's our node? Node is this one. Yes, to the one that we're going to be deleting. So we're going to assign the temps next to the node. Okay. So we have temp this इसका जो इसका नेक्स्ट होगा वो बेसिकली ये होगा सॉरी temps next ये node होगा and we're gonna assign it to node over here as you can see. Temps next is equal to node. I did it over here. Temps next is equal to node. Okay. Next, we're gonna do temps next is equal to nodes next. So we're gonna assign the nodes next. Nodes next is this node, and we're gonna assign it to the temps next. Okay, over here, as you can see, I've assigned this node's address to this node. So this is the nodes next, and this is the temps next. Temps next pointer. Okay. Now that's another way. Now it's gonna check if nodes next is not equal to null. If the nodes next, so this is the node, it's next. If it's not equal to null, which in this case it's not, it's gonna run the this code. Nodes next previous is equal to temp. This is the node. Nodes next previous pointer is gonna be equal to temp. As you can see, that this was the nodes next node. The previous node is assigned to this node. Okay, to the temporary node. Okay. And in this way we have a two-way link set up. Next is gonna just delete the node. Node is this, so if it deletes it, it's gonna go. It's gone. Okay. So let's just recap this a bit. First, we initialize traversal. In this case, the traversing won't happen as we already are at our location. Next, temp next is equal to node next. We assign temps next to nodes next. Nodes next was this one. Temps next was this pointer. We assign this pointer to this address, and then we do a similar thing over here. We assign what was that? We assign node next previous equal to temp. So nodes next previous pointer is equal to temp. We assign this previous pointer to this node. We create a two-way link over here, and then finally we delete the node which was whatever it was, like nodes next, temps next. Okay, we delete it. Okay. Now, this was, ladies and gentlemen, the story of how a doubly linked list works, and I hope you understood it well.